Okay, welcome back everyone. In this video we're going to be talking about circular motion, and we're going to start with a quick definition, and we want to start with what we call uniform circular motion, which occurs a lot in nature, and it's basically when an object is moving with a constant speed on a circular path. Okay, so what does this look like? Well, we can take a look at a little Ladybug app here, and what we have is circular motion, and we have both a velocity and an acceleration vector. So we can see that this is uniform circular motion. And some characteristics of uniform circular motion is, first of all, that the speed is constant, but the direction is changing. And what this means is that we have a changing velocity. Remember that velocity has two components, a magnitude, which we call speed, and a direction. And if I change either one of those, then I change my velocity. And of course, we know that if I change a velocity as time goes by, we call that acceleration. So it turns out that an object moving in uniform circular motion is also accelerating, and we call this centripetal acceleration. Okay, and we call that AC, and we calculate that by taking the speed and squaring it and dividing by the radius of the motion. So if I let this run again, what you notice first of all is that the velocity is tangent to the path at all times, and the acceleration is perpendicular to the path. And this is important because if that acceleration vector was pointing in another direction, then the velocity would not only be changing direction, it would also be getting bigger or smaller. For example, let's take a look at an ellipse. So now you can see that the acceleration is both increasing and decreasing the size of that velocity vector. Okay, so ellipses are a little bit more complicated. We won't talk about those just yet. We're going to stick with circular motion. Okay, and a neat thing to do is, if you want to try this, this app is called Ladybug Motion. Download it, and down here in the remote control, this is the acceleration. Put it on manual mode and try to get that ladybug to go in a circle. It's a lot tougher than it looks. And see what you have to do with that acceleration vector. Notice what I have to do. Doing a really bad job of it. Okay, well, you can try that. And let's just say a couple things about centripetal acceleration, and then we'll be done. So centripetal acceleration means center seeking. And if you break down the word centripetal, well, you have the centri part, which means center, kind of a Latin root, and then the pedal part is part of the Latin word to seek. So it's the verb peto petare. So centripetal is center seeking. And the last thing that we should know for now about circular motion is that we can calculate the speed by taking the distance we travel. So in other words, one circumference is 2 pi r, and divide that by the time. So that's going to be the speed of circular motion, and that's what you would plug in to here when you're trying to find the centripetal acceleration. Now, we will prove this relationship later on, as well as the fact that it points towards the center.